Welcome back, children. Today we will study about physical and chemical change. Well, in lower class you have also studied about these changes. Once more we will repeat the same. A physical change is one which is a temporary change, which is a reversible change, a change in which no change in chemical composition of the substances occur, a change which may not have any change in heat content. So, in a physical change, the components which are present, they will maybe change in state, or maybe there will be some variation in the physical properties, but the entire substance does not change at all. On the contrary, a chemical change is one which is a permanent change. In most cases, it is irreversible change. The chemical composition of the substance is totally different from the original substance. There is always some change in heat or any other form of energy is involved, and always a new substance will be formed. So let us go through the differences between physical change and chemical change. Firstly, the identity. In case of physical change, the identity of the substance is maintained. That means what? Whatever is the substance, its constituent remains as it is. Hence, the identity does not change, it is maintained. On the other hand, in chemical change, the identity of the original substance or substances is completely lost. Like supposing, when you heat coal, what do you get? You get ash. So from coal, which is carbon, you get ash, which is totally different substance, along with the evolution of lot of heat. So the identity changes totally. No new substance is produced. So in case of physical change, no new substance will be produced. For example, when ice melts into water, the molecule of water, that is H2O, it is as it is. In ice also, the molecule is H2O, and when it has converted into liquid form, that is in water, the molecule has the same constituent, that is H2O. So, no new substance is produced. In case of chemical change, a new substance is always produced. As I have given you the example of burning of coal, and you get ash. So ash is a new substance, right? So new substance is produced. Third, only the physical state or some of the physical properties of the substance are changed. Now, as I said, whenever ice gets converted into water, the physical state changes, right? Ice is in the solid state. When it turns into water, it is in the liquid state. So physical change. There is a change in physical state. Properties, physical properties. Now ice has a density less than water. It is about 0.91 gram per centimeter cube. So it floats in water. But when this ice gets converted into liquid water, the density becomes 1 gram per centimeter cube. So density is a physical property, so it may change. But in case of chemical change, the physical as well as the chemical properties of the substance are changed totally. Let me give you another example. When hydrogen and oxygen combines to form water, the entire molecule gets changed and a new substance is formed. Water is a compound, hydrogen, oxygen, they are element. Hydrogen, oxygen, both are in the gaseous state, but water is in the liquid state. The physical and chemical properties of water is entirely different from the physical and chemical properties of hydrogen and oxygen. Clear? Fourth, the change is temporary. Yes. Whenever ice melts into water, again, the water that is formed, if it is kept in a fridge, you will get back ice. But once you have burnt coal and the coal turns into ash, whatever method you apply, you cannot get back coal from that ash. So the change is permanent in case of chemical change. In case of physical change, heat change may or may not occur. Means it is not mandatory, it is not compulsory that some sort of heat change will occur in case of physical change. But in case of chemical change, heat change must occur. There will be some change in heat energy. Right, children? So, these are the various differences between physical and chemical change. Next, we will start separation of components of a mixture. The first that we will do is how to separate dye, means the colored pigments, from ink. For this, you require a beaker which is half filled with water. The beaker is kept on a tripod stand and from below it is heated. Above the beaker, a watch glass is kept and in the watch glass some ink is put, few drops of ink. As time passes, you will find the water in the beaker starts boiling and after that it heats the watch glass. As a result, you will find some vapors are coming out from the surface of the watch glass. As this continues, after some time you will find that no more vapor comes out from the watch glass. Then you stop heating. Now you see the watch glass. You will find only the colored pigments are left, whereas the water which was present has been evaporated. So, in this way, by the process of simple evaporation, the volatile substances can be easily removed from the non-volatile component. Now, in ink, water is the substance which was present in ink, which got evaporated, and the dye pigments, the blue-black ink pigments, they stayed back. So in this way, we can separate the pigments of dye from ink. Right, children? So we will do more of these in our next class. Thank you.